Alright, so this will be a little instructional video on getting some of those measurements that you're looking for in lab. See, we have a nice video of Matt here. So the first thing that I did was I actually pulled up, I did a chalk talk of one video, and I'm going to pull up another video so we can run them side by side. So what you're going to do is click over here in the other video window. So I want to pull in the other dumbbell press video, and that gives you the preview, so we want to get that lateral. So what we'll be able to do is we'll be able to run these side by side. After they're pulled in, I can click right over here. Alright, so I'm over here under screen control, and that'll give me the side by side view, and you can run them individually, you can run them simultaneously, so it's kind of a cool way to run your analysis. So we're just going to click in side view screen. As you can see, I've got the left side highlighted, which is the anterior view. I can just click on the lateral view and it shifts over, or I can actually click and lock them together. So whenever I hit play or use any of those play functions, it's going to run them simultaneously, which is kind of neat. They're not completely synced in, but what we can do here is we can unlock, pull this down to about the same angle that Matt is on the anterior view, and we can lock them in right there, and then they'll kind of play together. So this is running at full motion, right? So we have other options we can run at. Now if you look below here, FPS stands for frames per second. We can actually go at super slow-mo, which is going to be at 5 frames per second, so we can go really slow to look at some angulation. So what we're going to do is we're just going to go all the way back to the beginning, because each one of these has 2 repetitions to it. Alright, so a couple things that we want to start with is I'm going to click on my ruler over here, and in the frame here is our reference point. So I'm going to go from start to finish there, and basically what that says is the length of that is 38 pixels. Now each person is still going to have to do this so you can get the proper measurement. So 38 pixels, and as I uploaded and put on the lab, that the actual distance, the length of that dumbbell is 9 centimeters. So now you can simply create a pixels per centimeter, so 38 divided by 9, that'll give you your conversion. So that way if you wanted to actually go in and measure anything, for instance the length of his upper arm, it's at 43 pixels. Use my conversion, and I can actually get the distance of his moment arm right there. So real easy to make those calculations. So the other thing that I've asked you to look at were some angles. So basically what we've got here is the ability to look at Matt in this down angle. So what I've asked you to do is look at the angle in the shoulder joint right here from an anterior view. So this is going to give me my starting angle. So when the arm is all the way down to the side, that's essentially going to be 0. And we've done some markers here. Okay, and I didn't ask you to be perfect, we're just trying to get a guideline here. So essentially that first angle that he's actually starting at is 42 degrees. So that would be your starting angle. And then if I wanted to continue all the way through and look at his finishing angle, and I'm actually going to leave that on there. You can change those points, which is fine, but just in case you remember, we can go over here and erase all that. So you could clean those out and erase them, or you can leave them on there. So you can just erase the last one. You can pick which ones you'd want to erase. Okay, so we're just gonna erase it all. So now from this point, I would like to use. You can't really see the marker behind, but we're just trying to follow along. I mean, really, what we're looking at is the humerus in relationship to the body. So we use this as the same point. Okay, so what we get is 154 degrees. So if I take that number and I subtract my first measurement, that gives me my complete range of motion that Matt went through in glenohumeral joint abduction. Okay, if we wanted to, we could also do something in terms of calculating the displacement, so meaning where the weight started from. So I'm just going to go back to where his starting position was, and I'm going to do a couple things. One is I'm just going to kind of draw a line to where that was. Right, so that was my starting position. I'm just going to hit play, and I'm going to wait till he gets completely to his upright position. When it's not moving any further, that's why we asked him to move nice and slow. What I'm going to do is I'm just going to draw another line. You can change the color if you want. Alright, so that gives me the starting position, that's the end position. Then I'm going to take my ruler over here, okay, and I can just go from one to the next. And we're trying to get to 90 degrees, so it's perpendicular, and that gives me 79 pixels. And again, because we have our reference point, that can actually give me the complete displacement. And that would be linear displacement. So if we're looking for pure linear displacement of the object itself, we looked at the angles because that actually gave me the curvilinear, the displacement rotation of the humerus. All right, so we're going to go back and erase all those sorts of things. Back to the starting position. Okay. If we also wanted to look at some things like his angulation off of that frontal plane. So remember that your glenoid fossa, it actually points slightly off the frontal plane. It's not directly to the side. So in proper execution for this exercise, your elbows are slightly anterior to the glenohumeral joint. So I'm just going to start a point there. We've got another one here. Right? So we're actually 30 degrees off that frontal plane. I didn't plan that. That actually worked out pretty well. So that's the direction at which that glenoid fossa actually projects. Now, I also asked you to look at a little bit of torque. So torque is the distance. So we look at the moment arm, and the moment arm is the distance between the force of resistance and the axis of rotation. So I'm going to take a couple lines here. So this is my shoulder joint, so this is my axis of rotation right here. Now I'm going to take another line, and again we can change the color if we want. So back over here to the line. So we're going to use this midpoint right here, and so that's where the resistance is. So now I can actually calculate I want to calculate the distance here. So that distance, right, from the force of resistance to the axis of rotation is 30 pixels, and again I can actually calculate the length of that with the moment by using the conversion. Now, I didn't ask you to actually calculate torque, but you could calculate torque if you wanted to, because you have the weight. Right, so we can actually do the same thing over here. Now you'll notice that there's a slight angulation, so if I can make this nice and perpendicular, oops, I need to erase that. If I can make this nice and perpendicular, so I can get point, right? So that actually gives me 17 degrees. So if you think about it, if he were to hold this weight and actually move it backwards, right? So if he were to move that backwards and hold it directly over the glenohumeral joint, then he would be perfectly in line, but he's not. So he's actually 17 degrees. So similarly, if we wanted to, we could actually look at the torque not only as we did over here. So we looked at the torque in the in the frontal plane, right? But now we can actually look at the torque in the sagittal plane over here, right? So this on the frontal view, the anterior view, is actually showing us the amount of torque in the direction of motion. So typically that exercise is predominantly a frontal plane motion, but as we know, it's 30 degrees off of that frontal plane. So it's not purely within that frontal plane, but for our purposes, we're just gonna do our assumption based on that. Then the other thing, and I asked you to do this in one of the other ones, was to look at the moment arm. So that was the bent elbow versus the straight elbow. And so what you'll be able to do again is to look at the degree of torque. And so what's happening when this over here was 17 degrees, so that's actually creating another moment. So what he has to do is he has to resist that weight falling forward, which means that he must provide an external moment, external rotation moment, to keep that weight from falling in this direction, right? And so we can calculate that as well. We would do the exact same thing. Okay, so what I like to do is just take a line and run that through his shoulder. We'll take another color and we'll run it through the force of resistance. Right, and it's running parallel, right? And so we'll take that measurement at the glenohumeral joint, so right here. So we measure that distance, and again, I've got 20 pixels. I can use my conversion to give me the length in centimeters, and knowing that weight is 5 pounds, I could actually calculate the torque on the external rotators. Okay, so that's something that you're also to look at in one of the others. Well, I hope this was helpful. Again, these are the tools we can manipulate the speed. We can go back and forth frame by frame if you want to make sure that you're at the right point. So as though it looks like you're all the way up top, are you really there? So you can just simply go frame by frame, and if you notice, he starts to come down over on that lateral view, starting to come down over on the right view. So we could actually calculate that as well. And then just one other point. So what I'm going to do is I'm going to try and find a point right before he starts to move, and we're just going to use that anterior view, this one right here. Right, so I'm actually just going to reduce that split screen, and I'm going to go to video A. Whoops, I didn't want to do that. I want it to shift there. Okay, so what we're going to do is we're going to look at something here, and I want you to look at this frame rate. Okay, so we're at frame 102 of 571. So this was going to be our starting point, and I just want to make sure that it is in fact our starting point, because we're going to be able to calculate time here. Okay, so we can actually calculate the amount of time looking at the frame. So just another point, so we could actually look at the time it took to go through the full range of motion.